So hello everybody and welcome back to another video, and in this video I'll cover problem palindromes not allowed. That was from round status 44. So let's get started. So in the problem we have been given a string s that is of length n. So you can say something like hello, and you can rearrange the string such that it forms a new string that contains no palindromes. So you have to rearrange the letters of a given string to a new string that contains no palindromes. For example, we can rearrange hello into 𝐿, and it contains no palindromes, so it is a good string. So given a string, we have to tell if it's possible to form a good string, that is a string that contains no palindromes, or if it's not possible, we have to just print out no, that it is not possible. So how can we do this? So let's see. Obviously, there are only two types of palindromes, right? First type of palindromes that are even length palindromes, for example, A, B, B, A, and then there are odd length palindromes, for example, Z, A, C, A, Z. And if you see carefully, every even length palindrome will have a smaller palindrome of length 2 inside it. Every even length palindrome will have a palindrome of length 2 inside it. Similarly, every odd length palindrome will have a palindrome of length 3 inside it. So if you can erase all the 2 length palindromes and all the 3 length palindromes, then you can be sure that there will be no bigger palindrome in the string. So our goal is to eliminate all 2 length palindromes and all 3 length palindromes. So how can we do this? Let's see that. So let's start with two length palindromes. Let's start with eliminating 2 length palindromes. So to eliminate 2 length palindromes, obviously 2 length palindromes are of type, you can say A, B, B, C, C. So to erase these, it's just sufficient to place a gap between two same characters. For example, if you see 2 AA, you can place a gap here, and then there will be no two length palindrome. So it's simple enough to place a gap between two similar characters. It's easy as that. So whenever you see a, you will place a gap, then place another A, then place a gap, then place another A. Similarly, you place a B here, then you place a B here. So all the same characters should have a gap of 1, right? So that is how you can remove all the 2 length palindromes. So now let's see how you can remove the 3 length palindromes. So eliminate 3 length palindromes. How can you do that? So now we have already seen that if there is an A, then there will be a gap, and then there will be another A. But if you place a B here, then you can see that it will form a 3 length palindrome, right? So it is not enough to have a gap of 1 here. It is not enough to have a gap of 1. It is not enough to have a gap of 1. So between two same letters, there must be a gap of more than 1. So there must be a gap of 2 inside. So if there is a A here, there must be a gap of 2, then there must be a, then there must be a gap of 2, then there must be a. Then now you can place a B here, then you can place a B here, then you can place a C here, then you can place a C here. So now you can see there are no 2 length palindromes here, and there are no 3 length palindromes here. So now we have found a way how you can eliminate all the 2 length palindromes and how you can eliminate all the 3 length palindromes. So now let's try to apply this to our problem. As you can see here, you can kind of form a box here, right? As you can see here, you can kind of form a box here, a box of size 3 here. Similarly, A starts again, so you can form another box here, and similarly you can form another box here, right? So you can like break your entire string into boxes of size 3. So I will show you how that will help you to see the problem and how it will help you to solve the problem. So let's take a string for example, a b b b c c c d. So as you can see here, the length of this string is equal to 10. So you can form 4 boxes. Here's your box 1, here's your box 2, here's your box 3, and your last box is of size 1, right? So there are 4 boxes. So a very basic observation here is that if frequency of any element, if frequency of any letter x is more than number of boxes, then the answer is impossible. Right? For example, if frequency of a was 5 here, then you can fill a here, you can fill a here, then you can fill a here, then you can fill a here. Now you don't have any place to fill the last a, right? Because you have used all your boxes and you don't have any spare space left for your last a. So your frequency of frequency of any letter should be less than or equal to number of boxes. So if your frequency of x is greater than boxes, then the answer is impossible. And another observation you can make here is, for example, if your frequency of a is equal to 4 here, and your frequency is b is also equal to 4. Now you have filled 4 a's here, right? Now you have to fill 4 b's. But if you try to fill 4 b's now, you will fill a b here, you will fill a b here, you will fill a b here. Now you don't have space for another b because your last box does not have 2 spaces, right? So you will keep a variable that is last box space, right? Last box space. In this example, your last box space is equal to 1, right? So the number of letters that can have frequency equal to boxes, number of letters that can have frequency of x equal to boxes should be less than equal to last box space. That is your second condition. This is your condition 1, this is your condition 2. Like in the given example, your last box space is equal to 1. So there can only be one letter whose frequency is equal to 4. If there are 2 letters whose frequency is equal to 4, then your answer will be impossible. Similarly, if your box is something like this, then you can have a equal to 4, b equal to 4, then you will be able to fill here, right? Then you will be able to fill 4 a's and the space here, and you will be able to fill 4 b's, right? So that is the second condition. Number of letters that have frequency of x equal to boxes should be less than equal to last box space. So these 2 conditions are sufficient, and if these 2 conditions are satisfied, you can form an answer. So how can we form an answer? So that's very straightforward, but it's like kind of implementation based and it's tricky. Then you can like just keep track of boxes, and you can sort your elements by frequency. Sort your elements by frequency. For example, in the given example, we have A, B, 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 C, 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 and D. So our A's frequency is equal to 3. B is equal to 3, C is equal to 3, D is equal to 1. So we can, let's make C equal to 2 for now, and let's make A equal to 4 for now to make the example clear, right? So let's say here is another A, and we can remove one C for now. So we can say A is equal to 4, B is equal to 3, C is equal to 2, and D is equal to 1. Obviously A's frequency is equal to 4, so we'll start with A and fill all the A's in the first box. Similarly, then we will start with B and fill all the B's in the second box. Then we have two C's, we can fill the two C's here, and then we can fill another D here, right? So now your resultant string is ABC, ABC, ABD, and A, and it has no palindromes. As you can see, it has no palindromes. So that should be your approach, and there is an exception here, so let's see the exception also. So now let's start with AAA, BBB, CCC, and D. There are 4 boxes. A is equal to 3, B is equal to 3, C is equal to 3, D is equal to 1. So I'll start with A, then we start with B, B, then you start with C, 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 and then you fill D in the last. And as you can see here, there is a palindrome of length 3 here, right? There's a length of palindrome 3 here. So this is an exception to our method. So in a case you see a palindrome of length 3, after you have after you are done with the filling, you will form your string, right? So you will get A, B, A, B, C, A, C, D, B. After you're done, you will see that there's a palindrome of length 3 here. So if you see such a case, then like after forming your string, you can just iterate your whole over your whole string. And if you see somewhere a palindrome of length 3, then you can swap these two letters D and C, and you can just swap these two letters. And it's sure that after swapping, there will be not any more palindromes left in the string, right? It is easy to show also. So that is the whole solution. You can easily show this also, that if you swap these two letters, there will be not any more palindromes in the string left, right? And I will leave that to you, how you can show that. So that will be the whole solution to the problem. And if you want to see my code for this, I will show you my code. Here is the code for this. I start with my answer string. Then I start with the number of boxes, that is n plus 2 by 3, the number of boxes. And this is the number, this is full. My full is equal to number of letters with frequency equal to boxes, right? And then I keep a map to store frequency of my letters. If frequency of any element is more than boxes, then the answer is impossible, right? So it was my condition 1. If you see here, here is my condition 1. If frequency of any alphabet is more than boxes, then the answer is impossible. Otherwise, if frequency of x is equal to boxes, then I increment my full variable, right? Because I'm counting number of letters with frequency equal to boxes. And this is my remainder. My remainder is equal to last box space, the number of spaces I have in my last box. And if the number of alphabets having frequency equal to boxes is more than the last box space, then the answer is impossible. So that's my condition 2. If you see here, that's my condition 2. If number of letters that can have frequency x equal to boxes, it should be less than equal to last box space, right? That's our condition 2. And if these two conditions are satisfied, then we will start forming our string. And now that's just implementation. So here I start with my first box. My current box is equal to 0, and my box slot is equal to, like, you can say offset, right? So what I am doing here is, I start from my first box. I start from the first box, so its current box is equal to 0, and this is my box slot. This is equal to box slot equal to 0. So first I will start here and I will fill here. Then I will increment my current box. I will go to current box. Current box is equal to 1 now, but my box slot is still equal to 0. My box slot is still equal to 0. Then I will again increment my current box, and it will be equal to 2 now. Current box equal to 2, but my box slot is still equal to 0. And then I will go ahead. Then I will see that yeah, all my boxes have been all my boxes have been used. Then I will again go to the first box. That is, I will again do current box is equal to 0. But now I will implement my box slot. Now my box slot will be 1. Now I will implement my box slot. So now my box slot will be equal to 1. Then again I will go to second box, and my box slot will be 1 now. Then again, so on. You can like keep on adding your elements to the answer string. So here first I sort my alphabets according to frequency. So sorting my alphabets according to frequency. Why is sorting important? To show this, I can show you an example. For example, if you have a string like AAA, BB, BB, and how much example I take here? CCC, yeah. So it's 10, right? So if you don't sort here, you will fill all the A's, right? You will fill all the A's. But now you don't have enough space for B's, right? Because there were 4 B's. Now you don't have enough space for B's. So if you now fill B here, B here, B here, there is no space to place the 4th B, right? So it's important to sort here. And then here is the implementation that I talked about right here. This is my implementation code, right? So here is, so that's just my implementation. And then here is the exception case, right? Then there is exception case in case there is a length of palindrome 3 in the end. Exception case, there is a length of palindrome 3. So that was the problem solution, and if you guys have a doubt, do ask me in the comments and I will be happy to help you out. See you guys in the next video. Bye bye. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is 0 hidden fees, there is 0 upfront fees, and they are granting you a minimum package of rupees 5 lakhs. And the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि या मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long, and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below, and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.